Here we have a Dell Alienware R2 laptop that came in for repair. I do not know what year or version of the R2 this one is, but just look at the size of the board. I have not worked on a Dell Alienware motherboard that looked that small before. Alienware motherboards are usually twice or three times the size of this board. Everything is so compact. We have the CPU here, we have the GPU, we have the PCH, a lot of DR MOSFETs, a lot of inductors. And if we flip the board, RAM right here, and everything is so squished inside that board. Now the customer brought this in because he said the laptop suddenly would not power on. When he plugs the charging adapter in, the charging adapter itself turns itself off for protection. The charging adapter is probably detecting a short circuit on the motherboard, and that's why it's shutting itself down. We did attempt to plug the charging cable or the charging adapter, and we heard the tick. We removed the charging adapter, measured it, and we had 0 volts. So the adapter did shut itself off because of a possible short circuit on the board. Right now we have the charging cable right here, or the charging socket. It's connected. If I go back, I can show you the whole board. I go to the front, I cannot show you, so I need to get used to this. The charging cable or the socket is connected all the way to the side of the board. And we're gonna go ahead and measure right here to see if we have a short circuit, and we likely do. Usually I do everything in real time, but Big Boss did measure the current sense resistor on this one, and he confirmed a short circuit. So if we go to diode mode, and you can tell by the scratches on the resistor, we did attempt to measure this current sense resistor, and look at this. We have a short circuit right here. Our DC plug is connected right here. Since we are getting a short circuit on the current sense resistor, we're gonna go ahead and inject voltage here, and we're gonna monitor the motherboard under a thermal camera and see what gets out on the board. And it's very likely that we're gonna get a heat spot on the CPU, which is located on back of the board. And under the CPU, we're gonna have some DR MOSFETs right here, and one of them will be the culprit. One of those DR MOSFETs will be faulty. We're gonna remove the bad guy, we're gonna replace the DR MOS, and then we're gonna later find out that we have a dead CPU. I'm not trying to be negative here, but it's just based on my experience working on those boards. And the reason we're gonna have a dead CPU is because more voltage was pushed to the CPU than what the CPU could handle. And that's how CPUs go bad. Let's turn on our NF.short voltage injection tool. That's what we do anytime we have a short circuit, and we usually figure out the problem quick. Let's see if that's the case here. I'm gonna connect the ground to any one of the screw holes, or maybe the USB socket right here. And we're gonna inject voltage at the short and monitor the board under the thermal camera. So right now I'm injecting 1 volt, and if we check the motherboard, look at this. We see a heat spot at the CPU, just like I thought. I did not do this beforehand. We are doing it in real time. But I do see a heat spot on the CPU, and right now I'm injecting 1 volt. 1 volt is usually enough to detect heat. If not, then we can go up to 1.1, 1.2 as needed to see where heat is coming from. So we know that we have a short circuit on the CPU. And a heat spot on the CPU is likely a problem with the DR MOSFETs, which DR MOS is faulty. Look at this DR MOS here. It has 1, 2, 3, 4 pins, right? Look at this one here, 1, 2. It's like pin 3 and pin 4 are bridging. That's what it looks like here. Solder may have liquefied under the chip because of extreme heat from a short circuit, and they bridged. Possible. I mean, right now, we're gonna start with this one, remove this one, remove this one, remove this one, and we'll see. We'll take it from there. It will only take us a few minutes, not a big deal. Do we still have a short? And we do. Let's proceed to the other one. Flip the board. We're gonna do the third one. And let's measure. Now look at this, the short is gone. The last MOSFET that we removed released the short. Wow. Look at this, we are getting 0.3 and the board is still hot. The value is gonna go up to 0.4, 0.42. But it's unbelievable. I removed 1, 2, 3, 4, 5, 6 DR MOSes to finally figure out that the last one that we removed released the short. Let's jump to the second one, the third one, the fourth one, and then we'll apply flux again and go over every single one. And the reason I want to do it like that, because the board is still hot and it's easier to solder the other chips when the board is still hot. And I just grabbed a new chip, the 302045. I did not have one in front of me, so I went to the shipping room and got one from inside. And we're done. We are all done. Now we're gonna be using Amtech wipe to absorb the flux of the board. And we should be carrying and selling Amtech wipes probably later this week. You can check on our site, NorthridgeFix.com, click on shop. You can buy everything from original Amtech Flux. We are a distributor of the Flux. We sell everything from hot air station, soldering station, thermal camera, power supply, voltage injection tool, grinding pen, tweezers, braid wick, needle probes, multimeters, everything. Whatever we use on our bench here, we carry and sell in our shop. And the brush that we are using here, the ESD brush, a top seller in our shop. You can also buy at NorthridgeFix.com. Just add to cart, check out, pay, and we almost always ship out same day. For all of you who have ordered from us before, you know how fast we ship. We received a large batch of Amtech wipes, and the box looks something like this. We are trying to offer competitive pricing on those wipes, and at the same time, you get everything that you need from one shop. Not much money selling those wipes, but the fact that you can log into Northridge Fix and get everything that you want, even if we do not make money on certain items or we make pennies on the dollar, we still carry it, so you have access to everything. We soldered how many DR mosses? 1, 2, 3, 4, 5, 6. Now we're gonna flip the board and we're gonna measure at the current sense resistor again and see if we still have a short, and we should not, because the DR moss that was causing the short, we already replaced. Meter in diode mode, and we're gonna measure right here. Awesome, 0.35. The board is still hot, so it may jump up to 0.4, but the reading is perfect. The reading is excellent. All right, so I'm gonna hand the motherboard over to Big Boss to reassemble and test. The customer came in locally and he brought the laptop in a condition you do not want to see. Everything is taken apart. Big Boss is gonna have to reassemble the laptop, and hopefully we have a fix. I'll be back. It looks like this one is not going to be a fix, just like I suspected. CPU related issue. Look at how the fans spin and they stop. They spin and they stop, and that's a very good indication that we have a problematic CPU based on my experience working on those Alienwares. And if we look here, let's press on the power button, and the power button does change colors, but nothing shows up on the screen. And the fans, they spin and they stop. They spin and they stop. I knew it. Every time we work on an Alienware, it's exactly the same issue, exactly the same problem. Shorted the RMOS, we replace it, and then it ends up being a no fix because of a CPU related issue. We're gonna call it off for this one. I hope you enjoyed the video, even though it was a no fix. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.